Hi everyone. This video is to test whether the matching engine can correctly recover its order data from the snapshot and WAL after a crash and restart. Let me first introduce the structure of my code's aggregation engine. Within the engine, there are multiple instrument processors, one for each trading pair, and each is single-threaded to receive and process upstream orders from the aggregation engine. So what exactly does it handle? When it receives an order, the first thing it does is pre-match in the order book. But what about the result of the matching? It doesn't execute the result yet. It first writes this result to the WAL, and only after the synchronous write succeeds does it proceed to execute it. This way, if the matching service crashes, it ensures that the matching can be fully restored by replaying the WL to recover the order book's state after a crash. Of course, it also handles some mid-processing tasks, but let's not discuss that here. Every time 1,000 orders are processed, it triggers a snapshot, dumping the current order books in memory orders. Dump everything out and write it locally. Okay. This is the usual process for consuming orders. Each is pre-matched, written to the WAL, and executed after successful writing. Then every 1,000 orders, take a snapshot. When the service starts and restarts after a crash, its disaster recovery procedure is like this. It first reads the snapshot upon startup. After reading all the orders from the snapshot, it applies them to the order book. Then it remembers the last order in the snapshot. The order of the last order, suppose that order is 1,000. After all 1,000 are restored, it will read the WAL log. It starts reading from order 1001, and if there are any, applies them sequentially to the order book. Okay, that's the logic in the code. Now let's take a look at our test case. And now let's look at the test code. In the matching service, there's a WAL recovery test under the test section. So this test is to check whether the WAL in Snapshot can fully restore the data after the matching service crashes and restarts. Okay, so what does this test do? It starts by setting up, configuring the object mappers like the service, making some basic settings, then clearing the local WAL and snapshot files and completing initialization. Then it starts testing. The testing process is like this. It first writes 1,000 orders covering various boundary values. These 1,000 orders trigger a snapshot, and the WAL will also write these 1,000 orders. All right, after the 1,000 orders, it writes 2 additional orders. These 2 will only be written to the WL. They won't be in the snapshot. The next step is to simulate a system crash, then simulate system restart and initialization. After initializing the order book, we dump the orders from it and compare them with the original 1002 orders. We compare the order, price, and all states to see if they match exactly. If everything matches, the recovery is complete. Okay, that's the first phase of the test, which is to verify complete recovery. The second test is idempotency, meaning after full recovery, I will again replay the original 1002 orders to the instrument processor to see if the idempotent processing can fully block these 1002 orders. No duplication, no repeated processing. After execution, we then confirm whether the order status in the order book is exactly the same as the original 1002 orders. Okay, this is the second part. Finally, we will test the transaction, that is, after recovery, we will send new orders. Let's see if it can facilitate transactions, whether it can complete transactions correctly. If there are no problems, then basically the entire scenario will be correct and covered. I won't explain every line of the test. I'll provide explanations for some key parts to help you quickly understand the entire code. Here, we initialize the instrument processor because initialization involves reading snapshots and WAL. But at the start, those files were already cleared, so essentially nothing was done. Then we will generate 1000 orders for them to process. Now, isn't the generation of these orders quite interesting? The orders are generated using I, with odd and even numbers determining whether it's a buy or sell order. And the price is determined based on the buy or sell base price. Then add a number from 1 to 1000 divided by 10. Why divide by 10? Because I want every 10 orders to share the same price. It's like a group. I want each price to have 10 orders. So with 10 orders per price, I can ensure that when recovering, the order sequence is exactly the same as before the crash. That's why I divide by 10. And the quantity also uses I. And the order ID and user ID are I divided by 10. So basically, all the subfields of the orders are covered. Only the limit is not, because the system currently only handles offline orders, so only offline is implemented. Then we let it process 1000 orders in batches. And as mentioned, every 1000 orders trigger a snapshot. Then we send 2 additional orders, one buy and one sell, to cover both conditions. Here we simulate a system shutdown and then restart. The method to simulate restart is also very simple. Just create a new one and initialize it. During initialization, it will read slim pickup, apply the read data to the order book, then read the WAL and replay the WAL from the next log after the snapshot to the order book. Okay. After replaying and recovering, it reads the order book from the processor and dumps the orders. There's a part here to look at, which is the dumping process. You should pay attention to the dump order. The dump order is from BID first because it uses a list to receive the dump. First dump BID, then dump the asks. So the dumped list is in this order. It's the highest bid price, taken one by one from left to right. After processing to the right, then from ASK, where ASK is processed from the lowest price left to right, upward in this dump order. So it's dumped in this order, and when we verify later, we should follow this order. We should also verify in this order. Okay, now we start verification. It should match 1002 entries, then verify if the dumped orders are completely consistent in price, order, and status with the originally generated orders. The method is to sort the originally generated order set. How to sort it? That means buy orders are placed before sell orders. Since in our dump earlier we dumped the buy orders first and then the sell orders, so now our expected order values are also sorted in the same order. This way, the expected values and the actual dumped values will be in the same order. Then, using this method, he can verify by comparing if each field of each object is completely consistent. You can look up this method again using AI. In this way, the verification of the entire order book status can be completed.